Hey everybody, good morning, evening, afternoon, whatever it happens to be. I'm James of S&T Geotronics LLC, otherwise known as KM4YWT, and I'm here with you now to go over some programming of the S&T Geotronics LLC Open DSKY, this device right here. And there's been some controversy and some questions raised over exactly what this device does. And someone has said to comment that it's a three-trick pony. And they were referring to the test code that basically tests out functionality that was prepared for the first article that tested out whether or not we could read the GPS and whether or not we could read the IMU and process the values for the IMU and get the values to display and read the keyboard and such as that. So we're going to have a little video compilation of a bunch of videos that we're going to go over how the thing is coded and how the device works and how to program it. And basically this thing here can do anything that you can write a program that will make it do. And that's the beauty of having an open source thing with an open source community, is that the possibilities are actually quite endless of the different things that it can do. So anyways, that being said, we're going to go on and we're going to take care of a few basic issues that you have to get. A lot of people have bought kits for this, and some people have just purchased the PCB. You'll get you a nice pretty black PCB like this, hopefully. There are a very few green PCBs running around. Probably you didn't get one, which is okay because these here are prototypes, and there are some though that are working and run around and are doing their thing, and some of our developers who are working on code and playing with them right now have green ones, and that's just fine. The green one will do everything that the black one will do. Anyways, first things first, we need to go get some software utilities. The first thing that you're going to need is an Arduino IDE. Now if you have Linux, like this computer here has Linux on it, you're going to grab a terminal window and you're going to open the terminal, and there's the terminal window, and we're going to type in sudo, which is sudo for root because I want root's privileges, and then I'm going to give it the command of synaptic, synaptic. And if it comes back and tells you don't have synaptic, then you need to go ahead and tell it sudo apt-get install synaptic. I'm an old Linux guy, and I like my synaptic package manager. Nothing else quite works the same for me, so I'm going to start it and give him my password. And there's my synaptic package manager all ready to help me search for new software. I'm going to click on search. I'm going to type in Arduino, Arduino, and hit enter. And it's going to come up with the possibilities. And you see that the top two are checked with green checks in the box, which means I already have an Arduino. In your case, you may not. Not exactly sure how the new Red Hat package manager works, but basically all Linuxes that have a managed package system, even Slackware, has the ability to run Arduino. Of course, in Slackware, you're responsible for making sure that the dependencies are fulfilled, and it's your responsibility to know what's dependent on what in Slackware. In Debian versions of Ubuntu and Matebuntu and all the other Buntus and Mates and Mints and stuff like that, they pretty much handle this handling of dependencies for you, which is real convenient, especially if you're not used to running a Linux like a Slackware. Not to say that Slackware doesn't have its advantages now. Anyway, so if you don't have these two, Arduino and Arduino source code, probably you'll just click on Arduino and then mark it for installation, and it'll probably drag Arduino core along with it. If not, click that one too anyways. And then right here, once you add something new, I'll show you, I'll mark this one for installation. You'll see that my apply button is now available to push. And if I push apply, it'll go ahead and install that. I don't want it, so I'm going to unmark it. And that's the Synaptic Package Manager, and that's one way of getting Arduino in Linux. I recommend doing this even if you're not going to use it, because when you open the native version of Arduino, it's going to be smart enough to add you to the dial-out list so that you can actually talk to the Arduino. Otherwise, you may have trouble talking to the Arduino and have to go in and add yourself as a user that's able to dial out. And that's just a Linux tweak. Not really that bad. It beats installing a driver in Windows. But anyways, so that's handled. And then we're going to go and look at how to do this in Windows. So we're going to grab our web browser for all of you that run Bill Gates' stuff. And we'll drag our web browser over there. And we'll go to Arduino, Arduino.cc, hit enter, and have Google search for it. And then we're going to go to software. Boop. Right there on software. And there it takes us right straight. Google takes us right straight to where you can download the Arduino IDE. And of course, if you have Windows, you're going to want the Windows installer. And you can get it as a zip if you want to, and then expand it or unzip it. Requires extra stuff in Windows. You have to go get you an unzipper like PKZip. Well, actually, PKZip's probably already there, but you WinZip or something like that. And anyways, and there's a Mac OS X 10.7 Lion or newer. And somewhere you can search for old OS X if you have Snow Leopard or something like that. And of course, there's a Linux 32-bit right here. The 32-bit Linux usually will work on just about any Linux. You can get a Deb for a Debian, and you can get a what do they call it? You can get Debs and RPMs and all sorts of different things. Of course, if you have Debian, you can always get the RPM, run Alien on it, and make it into a Deb. Don't recommend that. And a Linux 64-bit version, should you happen to have you a good 64-bit OS of Linux, use the Linux 64. It's a little more powerful, a little snappier, a little quicker. And then there's a Linux ARM. If you happen to be running on a Raspberry Pi, there's another actual DSKY that actually runs on a Raspberry Pi. You could load this Linux ARM version of the Arduino IDE into the DSKY that's been made that has a Pi in it. And on its little tiny screen, you could actually go through these videos and write the code on that DSKY and have it plugged into this DSKY and actually program this one from it. Maybe I shouldn't have said that, but it's cool. Anyways, another little things, the checksums to see if you downloaded it correct, and release notes that tells the difference between this one and that one and this one and that one. And then you come down here, you got hourly builds, which are very, very unstable sometimes, but sometimes have real cool features, and beta builds. Let's just stick with one that they actually know works. So anyways, go ahead and install your thing to Windows, have an IDE, and go ahead and open it up and play with it a couple of times, and we'll browse on. For this exercise, we are going to need Lady Ada's library. Lady Ada from Adafruit Industries, otherwise known as Miss Freed, writes a lot of really cool libraries for really cool devices, and so we're going to say ADAFRUIT, Adafruit, and there it is right there. Google knows where we're going. Adafruit Neopixel library. And if Google didn't bring it up on your machine, that's the whole thing that you want to search for. And there it is, official seller. You can go right there and buy them. And it shows how to make them work on a Raspberry Pi. But we're going to go to Adafruit GitHub Neopixels right there. And there is going to be the library. There's the library for all the different stuff, the YUMs, the Neopixels, CCP, and .h, which are for the Arduino, and there's more other stuff in there. And you'll press this button right here, and it'll bring the whole thing down with you and put it in your downloads. It's going to be all zipped up, so if you're in Windows, you're going to have to get your unzipper and unzip it. And if you're in Linux, just open it with Archive Manager, choose Extract, and then drag the extracted folder into your Arduino library folder. If you've installed the one from the repository, it's down in your root directory and etc. and stuff, and you're going to have to find it. And but if you're that much of a Linux person, you know how to do that. And you'll probably have to drag it over there with root privileges. Real easy way to do it is to go into the terminal and tell them sudo nautilus, and then you'll open your file browser with root privileges, and you just drag the file right on over in there and drop it. If you've got one of the Linux 64-bit or 32-bit things off of the Arduino CC, you can actually even run it out of your downloads, or you can drag it into your root directory and make a folder called Arduino that has all your stuff, which is probably the best way of doing it. Anyways, and then just drag this library that's extracted from this into the libraries folder there, and it'll work for you just fine. You may have to rename it and get rid of some underscores. I don't remember, but I think that could be true. Alrighty, so moving on. I'm going to go ahead and close the web browser. We're done with it for now. Now I'm going to go over here and I'm going to get this Arduino IDE, bloop, and we're going to open this up, and we're going to make it a little bigger so that people can see it. There we go, a nice sized Arduino IDE. And I'm going to go click on File, and I'm going to come and I'm going to go to Examples. I'm not very good. Then Adafruit Neopixel, and then we want strand test right there. And we're going to open up the code, and it opened up somewhere else, and we're going to go fetch it, and there it is. And I thought that it would open up in here, but it didn't. There we go. I'll grab this and make it big enough that people can see it. And there is the Arduino strand test thing. And you'll see right here, it says include Adafruit Neopixel.h, and then it has an identify AVR and include AVR power.h, which is another little file that it needs to go. And then it ends the identification process. And then it defines pin 6. The relevance of pin 6 is that all of these Neopixels are operated by one single pin on the Arduino, which is pin 6, analog 3, digital 4, digital 6, which is that little pin right there between my fingernails. That one little pin does all the magic for this. So the next thing we're going to do is we're going to take our Arduino and we're going to hook it up. And we'll see that our Arduino has got little LEDs on it when we plug it into the USB that's hooked to the computer. And you can see that the Arduino is blinking a red LED. That's what this one does, because it has a red LED there. And of course, this other Arduino that was made by someone else, more than likely a Chinese copy, has a blinking LED that's, well, not red. And his other LED that says the power's on is green. Doesn't really make a whole lot of difference. If you get an Arduino from China, the quality can be different than other Arduinos. If you want make sure you have a good quality one, you can go to Lady Ada's site, Adafruit Industries, and buy one, and generally the ones that she sells will be of very good quality. But that's not to say that the Chinese one doesn't work. Anyways, the next thing's next. Let's get on to our board. In your kit, or if you just ordered the board, you'll have this beautiful black PCB. Took hundreds of hours to design this jewel, and we went through several iterations. Of course, you could possibly have a green one. This is the first article, the very first article. Kind of hamburgered together a little bit on a green board. Actually, the very first green boards had to fly a couple wires on them because it had a couple miswires, but they work. Still the same. It's just one little jumper that hooks something up that was missed when we designed it. We do our best. There's like 1,000 traces on it. Just missed one. So we're going to take our board and we're going to take a 470 ohm resistor. That is a yellow, violet, brown, gold resistor. There should be a whole bunch of them in your kit. If you bought a kit, probably 20 something of them. And that's a bag of 1,000. I'm going to get one, and we're going to install this 470 ohm resistor on this board. This resistor is between the Arduino microcontroller and the first Neopixel, and it is a buffer that helps increase the longevity of the Neopixel. If you look in the Neopixel library, it says right here, important to reduce Neopixel burnout risk, add a 100 UF capacitor across the power leads and a 300 to 500 ohm resistor on the first pixel's data input, and minimize the distance between the Arduino and the first pixel, avoiding connecting on a live circuit. If you must, connect ground first. Alrighty. Well, the board has a little bit of capacitance, and the Arduino actually has a pretty nice little capacitor on it already, and we're just testing this circuit out. So once you assemble the whole board, you'll see there's a whole bunch of 10 UF capacitors. We use tantalum capacitors that are really, really fast, and the buck converter that's built on this has plenty of capacitance. And so the total capacitance between the buck converter and the 10 microfarad capacitors that are all through the power circuit keep this thing nice and dampened. And we put them all over the place because we partially want to get the hammering effect of the switching of these Neopixels and also the Maxim chips. They actually hammer a little bit as they're switching the LEDs on and off, and create voltage transits. So that's why it has so many capacitors dotted all over the board, is to satisfy this requirement. For just testing the Neopixels for a short time, we're going to cheat. We're not even going to do it. Put the caps on. You can if you want, but I've never had a bad result by not doing it, because the capacitance of the board and the capacitance on the Arduino itself and the way the voltage regulator on the Arduino works usually handles the problem pretty well on its own. So we're going to hook up this Arduino, who's blinking his red light, blinkety blink, and then we're going to go over here to our Arduino IDE, and we're going to make sure that it says board Arduino Nano. And you can see that when I hover over this, a great big list of boards pops up. Boards Manager, Arduino SMD 32-bit ARM controller, and the Genuino programming port, and they've got a whole bunch of different Arduinos since the beginning. The original one is the Arduino Uno, which is somewhere, or an Arduino Genuino, native USB port. Anyways, they have lily pads and all sorts of stuff, and ARM 32-bit boards, and an Arduino DUI, which is a really, really good board, ADK. Anyways, the first one was an Uno. So anyways, we're going to make sure that Nano is selected, which it is. Then we're going to go to USB, and we're going to select the USB. If you're in Windows and you plug this in, Windows has probably got a little thing that pops up that says he's installing a driver, and hopefully he gets it right. If he doesn't get it right and fails to install the driver, go back to the Arduino IDE and find the correct Windows driver and download that joker too and install it. and then everything will be okay and you'll be able to talk to it. And Windows, depending on which nanite you have, which chip, which USB chip on the back of it has, may give every Nano a different USB ID, or it may call them all the same. But anyways, in Linux, it just goes and it says USB 0 usually, or it'll say Genuino or whatever, depending on whether it's a real Arduino or not. Nanos, usually it just calls USB 0 regardless of whether it's a real one or a cheap copy, because I think they all use an FTDI. So anyways, and everything else should be all right. And so we're going to say, yep, it's an ATmega 328, it's on USB 0, and we're good, and we have a Nano. And then we're going to go over here, and we're going to load Lady Ada's software with this button here that says upload. You see the lights blinking like crazy, and then it's done. And now it no longer blinks, it's LED. Because it's no longer running blink, it's running Lady Ada's strand test. We're going to unplug the Arduino from the USB. We're going to take our board, and on the back of our board right here, is the outline of the Arduino Nano, and you can see all the pins. And we're going to take our Arduino Nano and we're going to fit it right into the pinholes and push it down till it's flush. And then I'm going to show you this little trick that you do for testing. You take your thumb and you put it on the side of the Arduino Nano, and you'll see that it will rock in the pins, but it won't quite come out because the pins are long enough that they wedge in those holes. And we're going to put our fingers on the other side of the board, and we're just going to hold the Nano there just like that. And then we're going to plug the Nano in to the USB. It'll power up, and ba-boom. Uh-oh. Not all of them light. Imagine that. So this board has a problem. And in troubleshooting this, you'll understand that all of them are working just fine, all the way up to from 0 to number 9 work, and number 10 here isn't working. And the problem is more than likely either number 10 itself or a problem with the number 9, because the signal goes from one to the other. Each one of them thinks that they're device 1, and basically they subtract 1 from the total packet that's going around and pass it to the next one. So the first one says, okay, I'm 1. Is this package for 1? Oh, it's for 1. And then it applies that to its brightness and everything. And then the message is dead. But if it comes in and it says 2, then it takes 1 away from the address and passes it to the next one. The next one picks it up and says, oh, this is 1. I'm 1. And then it applies that, and then that message is done. All the way for however many there happen to be in a strand. Anyways, so if we look real close at this, and you look right here, real close, right here, you can see there's some suspicious soldering on this one. Probably the cause. Don't know for sure. Could be dead. Anyways, and that's what happens when it doesn't work right, just for your benefit to see one that doesn't work right. At least one of the problems that can happen. So we'll take our Nano off of this board, and we'll grab this other board over here, and we'll put our 470 ohm resistor in the resistor hole. Bloop. Just like that. We'll take our Nano once again that's already programmed. We'll put it on the back of it. I'll grab it in that special way so I've got a hold to it, just like that. And then we'll apply power to this thing, and hopefully, very hopefully, all of them will work. Boink. Now there's another manufacturer of DSKY out there who goes to great lengths to say that he puts 3 LEDs in every panel light. Well, guess what? We did too. Just so happens that one of those LEDs is green and the other one is red and the other one's blue. And red, blue, and green in the same little package. And as you can see, I can control The Adafruit strand test is making them brighter and dimmer in every color of the rainbow. So we don't have to use any yellow film to make anything yellow. We just give it so many reds and so many greens, and by golly, it's the shade of yellow that we want. They can make up to 16 million different colors, which is kind of overkill. But then again, there's lots of people that do things with a lot of overkill. This just happened to be a really neat, tricky, crafty, easy, simple, very adaptive means to an end, and only uses one pin on our Arduino to control all this, rather than having to add another shift register chip and having to add a shift register or use many pins and have a bigger controller to control a whole bunch of LEDs. Yeah, we've done that before. There's an Enigma running around that uses a Mega and uses a whole bunch of pins to multiplex a whole bunch of LEDs, and that works relatively well, but is beyond the scope of this. Well, anyways, now you've seen how we perform an LED test on the S&T Geotronics Open DSKY, and we've loaded our Arduino IDE, and we've went and got a library from Lady Ada from her GitHub. GitHub's a neat place, so you'll find all sorts of nifty stuff on GitHub. Lady Ada's stuff, even the original code that ran on the original AGC computer is there on the GitHub, all 8K of it on GitHub. And we're going to get some of it. We're going to play with some of it. And we're going to go through and we're going to talk about the math and how the AGC computer did its 15-bit math and how it stored negative numbers and positive numbers and all sorts of fun stuff. And we're going to go over maybe a little bit of the mapping of the ATmega 328 versus the mapping of the original AGC computer, and how we can actually make a little bit of this historic code actually run, if not all of, on our AGC. Of course, other people say they run it on stuff, and of course, if you have a gig of RAM and 4 processors running really fast, it's not much of a challenge. Nope, not much of a challenge with that much horsepower. But anyways, we're going to try to stick really close to what actually was. This little Nano has 8K of ROM, just like the AGC did, and 2K of RAM, pretty much just like the AGC did. Although it's 16-bit, and it has a little bit different architecture for storing negative and positive numbers, and we'll talk about that later on. But we've got a bunch of other things to go through between here and there. Next time we're going to talk about testing the actual 7 segments and the driver chip that drives those, and we'll go get the library for it and we'll start playing around with that in our next video. And this is the first video of the series, and we'll see you again soon. And this is KM4YWT. You can find me at 7.055, usually in the afternoons, running constant wave. I'm not very fast, not fast at all. And if you're slower than me, I'll wait on you, but probably you're not. Probably you'll be frustrated because I'm slow. But you're welcome to meet me there. And basically, that's what all I have to say on this video for right now, and I thank you for watching and hope to be with you, and we'll go over all this code, and we'll have all sorts of fun and make this thing do all sorts of interesting things. So, for now, this is KM4YWT, going clear.